Hi everybody, Patrick here from EngineeringShock.com, Engineering Shock Electronics. This is video 3 for the ES6937 motion sensing swivel disc. If you haven't seen the previous videos, like the setup video or Program 1 or Program 2 videos, they're linked below, as well as a Kickstarter campaign. If you haven't already checked it out, please do. It's a really neat Kickstarter campaign, a very small one, and I've already ordered the parts, so they should arrive in the next 3 weeks. In any case, I'm going to skip over what we've talked about in the previous videos because every piece of code is built off the last. So in this right here, the only thing we've added in the setup and previous to setup is we've added a new integer called state2, which we'll use in the waiting function. That's going to be one of the last things we talk about. But counter, state, and hold have already been created in previous videos. We're also creating two more integers and one long. Window high and window low, we're going to set to 0, and these are going to be used for our window comparator later on. And by window comparator, I will explain as we go along. As you can see, everything is fully commented. I'm just going to touch on everything. We've also got a long container, and we'll be using that in the calibration function. We're going to declare our built-in LED, which is pin 13, GPIO 13, and we're going to call it LED. Now in the setup, same as before. We serial begin 9600, which allows us for us to use our serial monitor and plotter. We use pins A3 and A1 as ground and power for our swivel disc. Again, previously talked about in other videos. Set LED as an output. Set A3 low. Set A1 high, and that will create a 0-volt reference for our disc as a ground. And setting A1 high will apply 5 volts per power supply to the disc. The disc doesn't take any power or very little power, so we can actually do this. And we'll wait 1 full second. Done. Now we're in the void loop again. Now stabilizer. We call the stabilizer function first, which waits for the sensor to become stable. As soon as you power it up or reset, the output of the sensor becomes wonky, and you need to wait about 30 seconds. Now, instead of waiting 30 seconds, we're going to call stabilizer, and that's going to run an algorithm that allows for the program to know, okay, things are hunky-dory now, we can move forward. So that was talked about in the previous video, again, linked below. From here, it says we'll do a serial println, which allows for us to print this to the serial monitor. Please leave the room for the PIR sensor calibration. Now, you don't need to leave the room as long as the sensor isn't pointed at you. But what's going to happen is we're going to run a calibration function. The LED will turn on because the sensor has become stable. We're going to wait 10 seconds for you to leave the room. Delay 10,000 milliseconds to 10 seconds. And then we're going to call the calibrate function. So let's go down and have a look at the calibrate function. Hopefully you can see all this. Again, everything is commented here. We're going to run a for loop, and we're going to sample the output of the swivel disc, which is connected to the A2 pin, and place the result in hold. And then we're going to say container equals container plus hold. So if container was 0, container now equals hold. But if after the second sample, remember we're taking 50 samples here, we want to keep adding every sample to container. So container is going to hold a huge amount. We're going to essentially 50 samples added together as a sum. As you can see below, we're then going to take an average by saying container equals container divided by 50. Then we can serial print the average, and this is going to be the average output. And we're going to use this as a reference point later on. Then we're going to print the actual container value. Okay, so now window high and window low. This is where we're going to create our window comparator. Window high will equal container plus 50. And window low equals container minus 50. Now you can play with these values. The smaller these values are, in this case 50, the more sensitive the unit will be. 50 might be pushing it. That's pretty sensitive, but you can experiment. That's what we're supposed to do with this. Set it down to 20, plus 20, and minus 20. Set it up to 200. See how this is the fun of this unit. This is how you're allowed to experiment. So basically, once the sensor has become stable, we get a value in container that represents what the sensor considers to be stable. So if it swings outside, if the value returned when we sample it later on is more than container plus 50, then we've got a breach. If it swings below 50 container minus 50 outside that window, then we've also got a breach. So there are notes here that you can look at. All of these code samples will be available to pledges of the campaign, but you can copy it and paste it. You can copy it if you see fit, if you're watching this on YouTube. Anyway, this is the stabilizer function. We don't need to worry about that because we talked about it in the last video. So we're going to go back up to void loop. So we've done all of this. We've run the calibrate function. We've created our window comparator. We're going to turn the LED off, set state to 0, print that the motion sensor is active, and we're scanning environment. We'll print that to the serial monitor. While state equals 2. So state is never not going to equal 2. We're basically just running this section over and over and over again because we've stabilized the output, we've calibrated, we've created our window comparator, and because we don't need to do anything else at this point, this is the point of the video, we're just going to run the waiting function over and over and over again. So here's the waiting function. We're going to take a sample of the swivel disk, place it in hold. If hold is smaller than window low, or hold is greater than window high, so outside of our window comparator, that's going to cause a trigger. Serial print motion detected. And as you can see right here, this is where you'd want to add your own code. This is where you want to turn on an alarm or whatever you see fit. You place your code in here because that's caused a trigger. After you've added what you want to add, we add a 5-second delay and run the stabilizer function again just to make sure that the output has become stable again before calling waiting again. So when this function is done, it goes back up here and it just calls itself over and over and over again. So this code was written so that you can easily modify it. Everything is fully commented, and I hope that it's been easy enough to follow along with. If not, the comments offer more than enough information. So that's the third and final video. I really do appreciate it that you've taken the time to watch. If you've pledged towards the campaign, again, give my utmost gratitude. But even if you haven't, I appreciate you being here. It's good to know that a few people are watching my videos, and yeah, I sincerely appreciate it. This is a really fun project, and if you haven't checked out the Kickstarter, please do, because it actually shows you what this looks like, shows everything in action. Take care of yourselves, everyone. Stay healthy, and thanks again.